this up, just as a reminder. You've got a ton of time for that big lab we're doing, but if you get to where, at this point I would expect 10's done, 2 is done, along those lines, I might clear off the table with all the generators and put them back in one of those boxes. Are you guys either done or have in your possession the generator you're working on? I'm going to rephrase that. Is there anybody that's like, no, leave them out? All right, I'm going to start moving them back. If you want to grab another generator and take it apart and do it, if you get towards the end of class and your project's done, that could be good to do. Get another look or a review. They will be in those apple crates that are out under the engine and the stand, so I'll get those moved. But yeah, so you should be done with 10, 2, and then 7, 8, 9 would be about what you're done working on, and today is kind of a design day. So just kind of keep pace. What you'll notice is I put in here other labs other than your project. You can just do your project, and get your project done here, and then work on your other labs if you want. There's no due date on these other than they're all due by the last day of class. So it's kind of on you guys to be managing and just staying on pace. But that's why I give you the calendars. It helps you say, hey, what would be a good pace for what we got coming at us?
Kate's just got to say, this calendar is incredibly helpful.
Thank you.
Yeah,
Thank
good.
you.
Really appreciate it. Yeah.
Glad you said that. Oh. Sounds silly, but sometimes you need those little things, because you can go a whole year and go, I did a good job. All right. This lesson today is kind of fun. We'll take some breaks. Shouldn't be too crazy long, but then you're like, man, you guys got to learn a ton of stuff. So we do got to kind of keep moving as we go through it. One of the big things is about our wire termination, terminals, right? So a terminal is a termination point. Is not destroying the end of it, but making it airworthy. So if you have AC 43 on your computer or even paper copy, you might want to grab it out. I did not change all my PowerPoints from last year, so when I go to 11.174, it's going to look like it's half a page. It should say the same thing in your AC 43. When you go to paragraph 11.174, it'll just be longer. But they tell me they didn't do edits that changed the meaning. They were just, what's the word you phrase it?
Clarification?
Not even clarification, visual edits. They were like, yeah. So the words shouldn't have changed. If we run across one that's like, that's different, shout at me, and hopefully next year I'll maybe go through and update it. But so page 11.174 should still say the same thing. Yes, Mr. Matthew.
Your highlighted paper says paragraph 11.7.
Down here. Well, 11.174. 11.174. You're right.
It is 11.174 though.
Yeah, because right here you're looking at it. So, the big thing there is the tensile strength of the wire to terminal joint should be at least equivalent to the tensile strength of the wire itself. So tensile strength means if I try to pull this thing apart, basically I shouldn't be able to pull the wires out of the terminal, is what they're saying, right? So it should be equal. Now, if they're the exact same, you're like, well, they fail at the same time. But that's back to where we get that from. It should be tight enough that when I have a connection and I pull on it really hard, we should be at the point where the wire's ready to break before the wire comes out of the terminal. To me, that's shocking, that's surprising. I don't know if that's actually true or accurate, but that's what they say it should be. Now that said, we're going to learn about these fancy ratcheting crimpers a little bit later. Shocking. It'll talk about using the right ones. I will tell you a couple different times that if you only do it once with these, which is what you're supposed to have to do, if you don't test that terminal, you will have a ton of terminals that aren't tight enough. And I'll go to your project and I'll be pulling wires off and it won't be good. So after you make them, test them, give it a pretty good tug, and, make sure they're good. Sometimes if I'm using the correct tool, I'll do it twice, just to be like, well, you know. Make sure, maybe Dean's got some better tips. I think the tip is buy a tool that works right. And, some of ours have been through a lot of SMAT students, so that might be part of it. But, yeah, should be plenty tight. Soldering the terminals, if you're gonna solder them, that one got a little hot. It does heat the copper, it weakens it, so that the vibration wouldn't be distributed all the way through the terminal. I talked about that once before. It's acceptable, but not recommended. The insulation needs to be stripped off the wire. I shouldn't have to say that, right? But, you know, you never know. Somebody's gonna decide that they're gonna put the terminal on without the insulation being stripped off. This picture is not aviation. This is just an electrician doing it, not in aviation school. I love those wire strippers. That's what I used a lot of. They were great because they got little pliers on the end. And you're gonna find rubber gauge wire and put it in there. The problem with these ones are you will often damage the wire where you go to cut through. And we're using wire that is really close to being almost too small for what we're doing. And any damage is bad. On top of, we're in an airplane that's flying and vibrating, especially vibrating. So if we start putting little damage here, that vibration will end up causing a failure point. In a house, well, hopefully your house doesn't vibrate. So, they don't have to be quite as careful when they're stripping wires. So, you can use a regular wire strippers, like something like this. These are terrible ones. I don't know why all the big box stores sell these, but they do. You can use a wire stripper like that. It's just highly likely you're gonna damage stuff. And the way those ones work is you're gonna put the wire in whatever the right size is. Hopefully, oops, wrong size. Hopefully not cut through the wire and you just pull it off. You know, works pretty good. The issue is you really should be inspecting it. That one actually wasn't too bad. Pretty close to see if you damaged anything. The better wire cutters, or wire strippers, excuse me, are these automatic ones. And what they do is they've got a jaw that comes down and grabs the insulation of the wire, and then there's a jaw that comes down and does the wire stripping. So on these ones, you gotta pick the right size, you put it where you want, get it in there. The jaw comes, and even before I strip it, it grabs the insulation side, and then it pulls it off. It's pretty cool. Those are really nice. That would probably be one thing to add to your to-buy list, if you know, these and spoons. I would have replaced your sheet metal tools with one of these and a spoon. They make different styles. Somebody bought one of these from Harbor Freight, I think it was last year, and they're having a lot of issues with where it grabbed the wire. It wouldn't grab right, wouldn't bite. I will admit, I did not use these for my heating and cooling career, so I still fumble with it just a little bit, but you get a superior product, and it's very, very rare that you're gonna cut any of the strands when you use the proper one. We got about 6 of these. This box lives in the tool crib, so practice them, get used to them. Find a buddy that's got one, use his, see what you got, you might wanna buy one. Grant,
Real quick, what are those called?
wire strippers,
The good ones. Like, is there a different?
expensive wire strippers. Klein, I'm sure Klein, I like Klein products, I'm sure Klein makes one. I don't know if Nipex does, I'm kind of a Nipex fan, but Klein ones. Joe?
The previous slide pertaining to heat weakens wire, vibration can't be distributed through the connection. I think I'm struggling to understand that. Are you saying that soldering, when you solder, the vibration doesn't flow through the wire, or it does?
So when you solder the wire, like say this wire that's kind of burnt looking, you heat up, if I was gonna draw the wire that's inside of that connection, right? You heat up the wire, And basically what happens is because it's soldered on, right here where the wire hits the connector, all of the stress from the vibration will be focused on that one point. So instead of the stress being distributed along the whole area that's crimped down, because the reality is one of those crimps, you know, it's squeezing it, but if the crimp was only this long, it wouldn't be strong enough. So that kind of tells you, well, it's using the whole crimp to hold it. So with a crimp, the stress of trying to pull out is going to be distributed across the whole crimp. With a solder, basically that end little spot where it's soldered gets almost all of the stress. And especially when you're doing vibrations, it's a combination of the end gets almost all the stress and you heated that wire up, so now it's more brittle. So you will have more broken wires. That is what the FAA says. You'll have more broken wires from soldered than you would from bad crimp connections. Now, obviously, if you're a terrible crimper, you know, it might go the other way around. But as long as you crimp them correctly, the crimp should be more forgiving, but also it should last longer without vibration problems. All right, wire strippers. All right, so here is a beautiful factory strip, if you want to say it that way. There's no damage. That's what it's supposed to look like. Here's one that somebody did heating and cooling, and you can see some damage here, and they're all getting kind of loose out there. There's some more damage on the strands here. Again, I think this came off online, but a conventional stripper, you'll nick a lot of those individual strands with the wire stripper, and especially on those small wires, if you're my age, you can't see it. It's hard to tell. Here's another picture. You know, if you're wiring a house or an air conditioner, not a big deal. But in aviation, we're not gonna be happy with all those nicks. Now, am I gonna cut apart all your connections to see if you nicked them? Unlikely. If you're the kind of person that nicks the wires, you're probably the same person that doesn't put the crimps on. So when I pull it out, not only did I pull it out, but there's a bunch of nicks in this wire. And or some of the connections, I can see where you stripped it, you know, even afterwards. So I'll inspect, I'll be looking for nicks, and you should be doing that too. This next slide is out of AC 43, table 11.13, and it tells you for your wire size, and this is the typical number of strands in the copper wire. So if we have a 18 gauge wire, they would say there's typically 19 strands, gives you a ballpark. And they're saying out of 19 strands in an 18 gauge wire, only 2 of them can be nicked. If you have 3 nicked wires, it is bad. You gotta cut it off and do it again, and hopefully your wire is long enough, right? None broken, none broken. So you gotta get all the way up to size 8 AWG before you can even have a broken wire. Now, apparently there's 133 wires in an 8 gauge if you're a normal aviation, because I think it's a 7 times 7, 7 bundles is, anyway. So that's why you can get up to 6 nicked, 6 broken. It's out of 133 strands in there. But there is a chart, so there's a chart to go by. I think every once in a while it'll pop up on Prepware where it'll ask you, hey, there's 3 nicked wires, is that acceptable? And you gotta go to the chart and say, well, what wire size was it? If you have aluminum, doesn't matter what size the wire is, and they only give you 8 to 333 because we don't run any aluminum wire below 8 gauge. In aviation, it just doesn't happen. I see that hand, I'll get there in a minute. If you have aluminum, it doesn't matter how many strands you can't nick it, and none of them can be broken because aluminum is not forgiving with that. So the chart does not apply to aluminum wires, or you could say it applies, but none of them can be damaged.
What is 0000?
It's really big, heavy. So if you're going from 18 gauge down, you'll get to 0 gauge, which is a pretty big wire. And then if you have a wire bigger than 0 gauge, how do we label it? We don't go negative. So they just go 0, 0, 0, 0, 0. It just gets bigger and bigger the more zeros you add.
And what is the gauge you most often see?
Most often, you'll be about 18-ish, 18 gauge is pretty common. You'll have bigger wires than that going to your battery and whatnot, those will probably be 10 gauge. The main, 10, 8, 6. And that's a review. We don't see aluminum much. Usually it's just from our battery up to the master or the bus if we have it. I'm getting ahead of myself. I got a slide that talks about it, so I'll just pause it there. We'll talk about it later. Demo the tool. I just did. I stripped it. There you go. Practice with those. The guy that bought it from Harbor Freight brought it back and got a new one, and the new one worked better. But, you know, I would say if you're going to spend the big money to buy I'm going to call it a fancy stripper, an expensive stripper, I would go all the way and buy an expensive stripper. That's going to last you probably a lifetime instead of the Harbor Freight line. Just saying. Joe.
I'm looking through here, through AC 43, and, table 1113 is not.
It's 11:15.
1115.
Did they change the table
Yeah,
number?
it did.
Yeah.
Oh.
It's on page 1171.
Okay. That's terrible. Alright. Do my edit little slide thing. You guys are paying attention. Alright. Dive deeper into the, whoa, man. Yeah, we're good. Dive deeper into the actual connections here. We like ring terminals, for multiple reasons, but I'll cover that a little bit later. Some of these are not aviation. This one, you hopefully will never ever see in aviation. Occasionally, you'll find this style on a connection, but not very often. This goes inside of here, and the idea is this part has a little divot on a piece going through that's kind of spring-loaded, if you will, and the little divot here would drop down into that hole when you push those two together. Normally, if you see this in aviation, one side or the other is going to have insulation all the way over it, so once the connection's made, it's kind of an insulated connection. They're pretty rare. We don't like them because theoretically you can pull it apart, right? But if the manufacturer got it approved with that connection on there, then the manufacturer got approved. Most of the time we're going to see these, or we're going to see more of what we call a Molex connection. I don't have a picture today of Molex because we are going to cover everything Molex on, it's a bit later, next Friday. So, we are covering Molex. That's where you've got the, I'll show you one over here. That's where you got the plastic where there's multiple connections all inside it together like these. So these are Molex connections. They're tiny little, ring things on there. Here's another, we call it Molex. So we're gonna cover these next Friday. So, and they take a different style crimper, so that's why we separate it and we make it a whole different one. Well, ring connections are what we want. If the wire size is over 10 gauge, we will not have insulation on it typically. The idea behind that, and as we show you how to do the crimping and stuff, is when we crimp it, we're both going to crimp down onto the wire, but also the wire insulation with everything. If you get over 10 gauge, we can't inspect to make sure everything crushed right. Plus, the force of crushing on that bigger wire is a lot higher and it'd split the insulation anyway. So, that's I call it a general rule that they like to ask prepware questions on is over 10, non-insulated, under 10, so physical size under 10, there'll be an insulated terminal. Can I buy these at Harbor Freight? Where do I get them from? It gets to be a little bit of a fishy world there. As long as they meet the military or MS standard, you can use them on your airplane. So none of these are stamped PMA, so it's not like you're gonna grab a connection and be like, is this an aviation connection? Oh yeah, it says PMA on there. So, yeah, you can use cheap, junky Harbor Freight connectors if you want. They're getting better every week, is that what the advertisements say, right? Their tagline on all the videos is, we're getting better and better. Like, well, yeah, considering where we started at. So anyway, they do like this question is, are they PMA connectors? Not necessarily. They technically have to meet the military standard, but how do you know if it met it? So the purchasing agent would kind of be responsible. I bought these from Amazon. I doubt they actually meet the military. Part of it is, one of them probably does, but usually in aviation, what you covered in Mats and Pros is how often are they tested on the assembly line, right? So is it 1 out of 100 of those is bad? So usually aviation is gonna have a more stringent testing, but connections, we don't necessarily follow that. But yeah, we do want the ring ones. We don't like the split or forked. And we kind of don't like solder.
Just
All
question.
right. I'm gonna catch him unless we
Yeah,
forgot his.
the over 10, that's a number over 10, so a smaller wire.
So, 10, 12, no, the other way around. 10, 8, 6, because it goes backwards, right? 10 gauge, 8 gauge, 6 gauge would all be uninsulated. I got a couple slides coming up with that. All right, peace.
That was my question.
Good, yeah. The over questions like, so bigger wires. So here's a picture. Here is a larger than 10 gauge, physically larger than 10 gauge, which makes it probably an 8 gauge or a 6 gauge wire. It's non-insulated, right? So, big wires, non-insulated.
In case,
Yes.
why is it that with sizing wires, the smaller numbers seem larger? Like, did they just assume that wires are going to get smaller?
I'm trying to remember the reason on the wire gauge. Shotgun gauges, it's because it's the size ball that goes down the shotgun barrel, how many of the balls to make pound of lead. So that's why a shotgun gauge gets bigger ball, the less ones there are. So I'm assuming it's something similar to that, but I don't know the actual reasoning. We might have covered it in general, but I forgot. But yeah. It's something similar. The English people, you know, if we were metric, we wouldn't do that. We'd call it millimeter. But we gotta be better than that or different. Here's why the ring terminals are better, why they're used, why they're superior. Imagine you're putting your nut or your bolt on there. If this was a forked or a split connection and there was no material in there, you'd have part of that connection where there's no pressure on it. So you're gonna have kind of a angled or you're gonna have an angle for the force. So not only would the nut actually wanna kind of sit sideways, but then also you'd be missing that whole piece for making your electrical connection. So it's both a physics, like the torque, and then also we get the electrical connection all the way around. So that's one reason, is distributes the electrical load well over the clamped area. The other reason is, well, unless the nut comes all the way off, you're never gonna lose that, right? If you slightly loosen the connector on a forked terminal, that wire can fall off and go find other things in the aircraft to send electricity through. So that is why we like ring connections. You will see these, we call them stake-on or push-on. They do show up. So especially, and I'm gonna use the word avionics, but low amperage connections where you just have to turn a solenoid on or off. They do show up on the back of PMA parts for aircraft, and if the back of the part has the stake on for that, you're like, well, I guess that's what we're using, right? Try to avoid them, especially on your projects. Just try to stay away from them. Now that said, if you're using those little black cube relays for your relays, well, those all have these, right? So it is what it is. But if you can, try to stick with the ring terminals. I think that's the general consensus that the manufacturers do too, when you're looking at them. All right, here's where it says on AC 43, crimp terminal lugs. The crimp on the terminal lugs and splices must be installed using a high-quality ratchet-type crimping tool. So, well, shoot, there goes using the crimpers that are, well, that one doesn't even have that example. Where'd it go? The crimpers that are built into the teeth on here, because these are designed to be able to crimp down the various electrical connections in here That's what you'd use in the building trades, heating and cooling, stuff like that, is you would use, that style that crimps it. That's not acceptable, it's not approved for aviation. It says you're supposed to use the right one. Now, that said, so get a good one. If the crimp's too deep, it might cut or break some of the wires. If it's not deep enough, it's not gonna be strong enough, so, they're saying use the right tool. Alright, notice the crimp, part of the crimp is on the wire, part of the crimp is actually, on the wire jacket or the insulator. Part of that is it gives the whole wire more strength. Remember, when I go to pull that out, I wanna have part of my crimp holding insulation. So I'm gonna show you how to use it. The problem with showing you how to use it is, well, it's hard for you guys to see way back there, right?
So we have geese.
What?
We have our secret weapon.
The camera? Yeah, even that, it's just not good. You'll get plenty of experience making all your own crimps. This big green box lives in the, yeah, okay. The big green box lives in the parts room. It's got, this is normally where you're gonna get all your connections from. One of the big things is you want the correct size. We're gonna cover that in a couple pages. I believe that's the correct size for that one, so I'm gonna carefully put that, oh boy, it's not liking me. That's the other reason we're not gonna show you right up close, is I want you to see how bad I'm doing. So I'm gonna put it in far enough, and part of the trick is, with some of these connections, if they're not good aviation ones, you're like, how do I crimp part of it down onto the sheathing? Because some of these, the metal part you're crimping is so tiny. I don't know a good answer to that. We'll ask Dean. So basically, we're just gonna put it in. Now, if I put it in and I do 1 or 2 clicks and I decide I don't like my positioning, the problem with these are they're what we call ratcheting style. I can't open it back up. It's stuck. I have to finish. Now, there is a little trigger mechanism on these that you can release it with. Don't go part way and pull it. It will break these and they'll be bad. So either finish the crimp, cut the wire, do another one, or try to find the trigger mechanism to release it. When you get a good view of these, you'll notice there's actually 2 different teeth that are gonna clamp down on that. So if I was gonna draw it on here, it's actually gonna not do one big flat crimp, but it's gonna crimp here, and it's gonna crimp there. There's 2 teeth, 2 spots. Some of these I've seen, it's actually a little bit deeper crimp on one side than the other. It's designed for, hey, one side we're only gonna crimp onto the wire, so you would theoretically wanna crimp it farther. The other side is going to crimp onto the wire and the insulation, and it's not quite as deep. Yeah, so you just gotta know your tool pretty well, which one you're using. If that's the case, typically you're gonna put the dot that says the color connection you're making towards the raw wire side, because typically the dot is going to be the side that is the tighter bite, if it's that way. Part of it's just knowing which one you have. Oh. So, we're gonna go down, we're gonna crimp it nice. Now, it's crimped both the insulation onto the housing, which I don't know how tight that's gonna grab, but also the metal onto my wire. So, in a perfect world, see, not so great. So, is it the tool's fault? Should I grab the wrong tool and do it again? So, one of the things you can do, if your wire is just a little bit too small for the connector, and you're like, hey, you're gonna cover in a minute that shouldn't happen. Well, some of the connections only go so small, and especially when we're using tiny wire for, let's say, control, or maybe you guys' projects, where on you guys' projects, we've got this blue wire, and the white wire in the bottom is very, very thin stuff, and it's actually like Teflon coated insulation. It's pretty fun. Kind of hard to work with. Dean doesn't like it. But we don't have connections that are like minuscule tiny. So one of the tricks that you can do is you fold the wire in half, and now I have twice as many strands. If I was to go and measure what gauge wire I have, I basically just doubled my wire gauge, or I doubled the circular mills, right? So the connection doesn't really care if it's folded over. You might say, hey Case, you just weakened the end of it, and I would say, well, realistically, by the time we get to there, I've already transferred my electricity anyway, so I'm not so worried about it. So folding it over is doing the exact same thing as you will see where you have two wires coming into one connection. It's a little more rare in aviation because we do want to be able to separate them, but there's nothing wrong with having two wires coming into one connection, other than it just doesn't look very professional. Doesn't look as good. So if the wire is very small, like what you guys are doing, fold it in half, put it back in there, do it again, and that's where I go. Did that go all the way? I think this is one of those cheap smat ones. I might give it a second. Oh, I pulled too hard still. So anyway, I gotta be careful how hard I pull. I'm gonna try a different one. We're gonna see what happens. I might not like that guy. Where? Uh-oh, we used to have like 8 of those. Somebody might have pulled too hard on the jaws on that one. Alright, let's try one more and then we'll take a break. But you get to see where if all you did was quick jam your wires in there and throw it on your project. Yep, so this is one where it bites deeper on one side than the other, I think. Alright, let's try that. Oh, that felt better. That was nice and tight. Alright. See, I'm not gonna go absolutely crazy on your wire, but theoretically the wire, so I should be able to grab it and do that and the wire's not coming out. So those first 2 or 3 I made were bad. So yeah, I would maybe avoid the red ones on here, or at least with a small wire, because I had, 2 or 3 bad connections in a row. I switch over to that one and okay, you get the idea. What's actually happening with our Molex is it folds it around. We're not using that. This is more the building trades where it puts a dent in it. We're typically not using that. We're actually doing this style where it compresses the whole thing in on itself. These ones actually will not pull out. So in the building trades, this is the one I used. I love those. But you can damage the strands easier. So that's why we're not using it in aviation. Where's my pointer going? We'll play a little game called Find What's Wrong, and then we'll take a break. Anybody have a couple, if these were aviation connections, what's wrong? Get rid of the forked ones, right? So right off the bat, you go, that's not aviation.
Spade's not preferred.
We don't necessarily like that, but it's a maybe. Same with this.
No protective layer on the middle one.
On this one,
Not the fourth, fifth one from the left.
that one,
Yeah.
that's actually a Molex that goes inside, so not the end of the world. That one might be okay. But, so on this one here, we don't have anything crimped on the insulation part, but the other part is we don't know what size that is, so we'll give you that. It's blown up. Is it a big wire? Is it a little wire? If this is under 10 gauge size, so if it's basically 12, 14, 16, 18, 20, it should be insulated. But it's hard to tell from the picture what size that is, so I'll give you that. All right, let me hit the pause button. I was gonna say break, but it might be on my thing in just a second anyway. Nope, that's a good spot for a break. So we'll take a break. When we come back, we'll do a little race. racing and get started. So at 5 after, come on back in.
Standing over with a single shot.
My grandpa gave one to me. That was fun. I took it to Mickey's. That's the most fun I've had.
Yeah, I like these ones. Difference with yeah, this one's labeled in millimeter. So, and unless I'm doing it wrong, which I don't think I am, it's got a little extra tightness. It's possible, I just don't know how I'm working.
I have them somewhere.
I just gotta admit, I'm not a huge fan of these, cause these red ones, especially when I'm doing red connections, half the connections I do pull out.
It's like technical donor because I love when they don't pick it up. What did they need? They needed for them to build a hanger, so I was like, I can make a video. That turned out well too. Here, I have that one. I guess you have a separate. Yeah, well, a film camera is like nothing connected. Completely separate. Oh, there's my dear picture. Yeah, that was fun.
Is this?
This is like no editing.
That's ratcheting, man.
So I got like
Let's see how yours is.
close to.
Yours is about the same on both sides.
Well, this is
Catch that one?
very
Yeah,
old.
let's do it.
I don't even know the name of it. Very old.
You wanna strip it or me?
I usually
Hey.
shoot on a Sony.
Okay.
Oh, I got some skyscraper. I would just snap it.
We'll clean up in here when we're done.
Yeah, just let you know. You know the bean? Oh yeah, I know the bean. Yeah, so we were at the bean.
These cars are terrible.
Cool, and then I think
Okay.
this one's at the bean, right? Yeah, so you can. Oh yeah.
And what'd you say was gonna break if you pulled the ratchet?
There's something on the, like the gears and all the mechanisms. So if you ratchet it partway, try to pull it back out.
Oh, just pull it.
Dude.
Yeah.
Oh, okay.
Every year people do
This
that.
was a good
Wreck
spot.
ours.
I'm still
There.
like,
So I was doing these guys.
Yeah.
yeah. Those
So
were
try one of those and see how tight it goes.
We were walking on the bridge and there was a hole in the bridge. Yeah. That's been.
A lot of
Typically, I
time-
like setting it.
I was just gonna say, a lot of times being in there first.
Yeah. Yeah, but,
Those look well used. Did you use those in the field?
Sure.
Okay, so
do you like to go hunting?
Nice and tight.
I'll hunt.
And right on the edge.
These ones also clean?
So that's where it gets to where you're like, and we might be, if we check our chart, for instance, those reds are good for 16 to 22, so this should be good.
How far do you want sticking out? Probably not that far.
Yeah.
You don't want it under the screw, so basically hardly sticking
I
out at
don't
all.
usually practice like the waiting element of
Case,
photography.
Yeah.
do you watch Electro Boom at all?
He'll show up later in the year even, yeah,
Okay, there's another good channel, and I watched a video last night of my favorite YouTuber
yeah.
wiring 100 car batteries in parallel.
What do you do with it?
That's the
I mean,
question.
in parallel is just, it's the same voltage,
Yeah.
it just lasts forever, but.
He would like take a bolt or something and put it between the two terminals, and it'd like make a massive explosion.
That's how
It was cool to watch.
What's his name?
It was Styro Pyro.
Oh, that guy.
I like Electro Boom. I think one of my issues with him is as he got more popular, because part of his fun part is the surprises.
Yeah.
Is he started getting where, cuss words and swear words. It's like, oh man, you were so good, you actually didn't have to add that. For me, it's like a comedian. Like if you're talented, you don't have to be swearing a bunch. But, so he kinda went down that road, but depending on what
case.
Yep.
So hopefully one day I'll get it. You'll get that one shot. That's awesome, dude. Yeah. Very cool.
It's a shame that we can't use, the whatever wire strippers, cause I got 2 free ones from Home Depot.
Well, you can use them, it's
Okay.
just, you better inspect very close to make sure you didn't nick anything, right? Once you have these accessible to you, especially in aviation where, you know, in a house or something, you know, if you cut, we'll do it again, but you're in an airplane, you're like, I only got so many shots at this before the wire's too short.
I try this.
They become really good. My thing is I had, you know, just years and years with my other strippers, these ones. So I got real good at it and not nicking the wire.
Oh, well, these are too small.
So once you get good with a certain set, then
Oh
to
my
get,
goodness.
then to get practice up with another
Does
set
it
takes some
yeah.
time.
They're so easy.
What?
I was gonna get them, but they were like $30.
Yeah,
I was like,
it's
you know,
one of
I'll take
those.
the Milwaukee like $12 one over it.
If you were doing wiring in aircraft all the time, and the shop you were working at didn't have one, it'd well be worth it, cause like one bad connection pays for it. But, it's interesting, a lot of shops nowadays are gonna have all these tools, like, so, like if you go to Amway with Rig Tour, I'm trying to think, I don't know if any of those guys have their own tools.
Did you get some?
Really?
Yeah, 'cause part of it
I
is
think
like
they're
down
that
there, you
expensive.
scan out to get the tool.
There's kind
Yeah.
of, some that were kind of
It
like
knows,
this.
and you're gonna scan.
Oh, okay.
I don't know where the.
So they don't want everybody's individual tools. Now, that's one of the
That's
nicest
interesting,
hangers
wire
around.
Alright.
So compare that to FBO, right?
Yeah, channel lock.
But,
They look good, so.
a lot of the missions are getting similar, where the overseas base has a tool set. So like Samaritan Aviation, we had a bunch of snap-on stuff
Yeah, those
donated,
things are
and
kinda cool.
like our new mechanics, they can bring their
Yeah,
tools if they
we should
want,
get it.
but we already have a full set,
Yeah.
so.
$30 on Amazon.
What are these? Jaws.
Print dies.
I was gonna say. I wonder if we could swap out.
Yeah, most of them have replaceable feet. Yeah, this one, what is it, 2 screws here?
Oh,
Broke it?
Yeah,
So Case, check this out.
This is similar to yours.
yeah.
But
This
it's
is
got-
the style that the Harbor Freight guy bought. We'll say this style. Last year, somebody bought, basically Harbor Freight makes a knockoff of that.
Okay. But yeah, you can tension it.
Yeah, theirs, the problem was, I think it was either no tension or the tension didn't work.
Okay.
So they kept, basically, it would slip in the insulation side, and then the teeth would start biting the wire, and it'd like pull through, and it
yeah.
just.
But the problem is you gotta get it like set. To the proper.
But like, you're not supposed to just take them.
So, I might go on a heist.
You know where one is?
No, but at around Grand Rapids.
Well,
Red Bull.
you actually had stripped out already.
Oh, did I?
Yeah. We'll try again. There.
I think the giant Red Bull. There's one time around there.
David, you gonna do this?
Regular pecan beer.
Oh, that's beautiful. Look at that.
I don't know.
Yes, sir.
Hey, can I put those in the
Literally
when
just-
everybody comes
so
back?
you can do any gauge?
I find that hard to believe.
Sir? Hey, Marlon, you want some salt and red show us?
Yes, sir.
Yeah.
Yeah, look.
Oh, sorry. Go for it. If I pull that right out of your hand?
What I do, so I push it here.
No, you just set it.
Don't do that one. Sorry, that's my display.
Here,
Don't
take
do
that
that
Label here, yeah, sorry.
You just set it up against that corner
Those are my displays with labels.
and then you squeeze it. So it grabs,
There, that's there.
and then let go.
Get some smelling salts.
Alright, welcome back.
Unbroken wire.
What, oh, but it's got a tensioner, you can loosen it up though.
Okay.
I'm gonna show you under the camera a minute, the Smat one versus Job's good Klein brand. And, the Harbor Freight one's kinda knockoff of the Klein brand. So on this one, you get where it grabs the wire, it's hard to see here, and then strips it over there. So you'll get a good view of them when you're using them. But, so there's even a couple different styles of these. Hard to tell, but it pulls off. So, Klein makes a nice one. What's interesting with these is it's gonna grab the wire here when it comes down, and this side is actually the stripper. It actually only cuts the insulation on opposite sides and grabs those two sides and literally rips the insulation off. So, kinda cool how it works. You just put it in there, it's gonna grab it here and then rip the insulation off on that side. And usually you're gonna get it set for whatever wire you're using, cause there's little tension adjustments here. So if the stripper's biting too deep, you can loosen it. So these are really, really nice. They work great, and for doing a lot of connections, you're not gonna nick them, especially once you get set. So that's the version that the Chinese patent people ignored when Harbor Freight made theirs. For that. But before we get too much further, we got a little rematch going on here. Hey, you can't pre-form it.
Oh, I can use a different one.
No pre-forming. Where do you wanna work from?
David, get up here.
David, you wanna redo? Okay. I'll move down in front of you guys. Okay. So I'm gonna say three zip ties this time.
Oh.
3. Get yourself set up. Yeah, we're not having any more of this case
Are you
messed up.
doing 3?
I'll do 3. Yep, I'll do 3 separate.
3 separate.
All right. Okay. Did we say is this double or nothing, or is this just more for more ice cream?
I don't want you to have to give us 2 ice creams.
Oh, I should. My diet's not working out. I got a lot of stress in life. I go to Culver's for lunch.
We're
Yep.
not.
I'm actually going to K-Pot tomorrow with some friends that are old. I don't know if you've ever been to K-Pot, but it's all you can eat. One thing's a broth bowl where you put food in. The other one's it's a Korean barbecue grill. Yeah.
You should tell your wife here that the chef is pretty handsome, because you can cook all your own.
I will use that. I'll use that when I'm there. I heard the chef here is pretty handsome. You cook your own food. It's expensive, but anyway. All right. Ready? We'll have somebody else say on your mark, get set, go. Oh, I'm just gonna do it over top of these. You guys
Don't
yeah.
blow mine.
Do we have judges?
You guys.
I'm hoping I blow them out of the water as nice and close, but I could be wrong. All right, Shane, give us a on your mark, get set, go.
On your mark. Get set. Go.
Oh no, it's a bad start already. I'm just bad when the pressure's on, I guess.
Rebel's like halfway done.
Am I hearing zips already? What is going on down there?
It's like really close for doing it once.
You might get. Take a breath, relax. Your head.
Is that better? Oh no. Oh no. Oh. I'm hearing a lot of zips. These guys are good at this.
Yeah, David.
I see like I got 6 on case. Is that what he's doing down there?
Rex.
Oh,
Oh.
you getting case?
Oh, shoot.
Oh boy.
Now, admittedly, well, neither of us cut the ends off, so there's 1, 2, and 3 down here. All right. You guys are good sports, though. I'll admit, you're pretty good at that. That is a very tricky skill, is to get a zip tie one-handed. So.
Alright, Case, if you're taking an extension panel, I'll do it your way.
Well, just while you're here at SMAT is my recommendation. It's kind of like when you're torquing hydraulic lines. I highly recommend both using a torque wrench and counting flats while you're here in the school setting. just to give yourself confidence. So once you leave SMAT, if you move over to cable ties, hey, you're the mechanic, but make sure you're not doing them in the spots that would be illegal. In areas of swamp, UV areas, if the zip tie, breaks, the wire has to not be where it's gonna get damaged on anything, so. Yeah, I think what you'll find is after you use lacing for a while, you'll like, you know, that's nice, and it'll set you apart from the other yahoos that don't know how to do it. Alright. Get rid of these, we'll get back into the other stuff. Some of these slides I think I mostly covered. I did give a size here. It's interesting when you look online, you're trying to figure out what size goes where. This one's giving me a 16 to 22 on red, 14 to 16 on blue, 10 to 12 on yellow. That should be standard across the board. If you're doing a whole project, you might, look into what size it has. Otherwise, just copy what's already on the aircraft, right? That was just where I said, hey, go ahead and fold the wire over. If you have to put two wires in one, back to this one. You're like, well, what if I have two wires that are 16 gauge? You're like, well, you could go to your chart and count up the circular mills and put your two 16s under one of these. The only reason that would approach being an issue is remember we can only put 4 terminals on each stud. And later in this slideshow I do have where it shows up, where it drops it down to 3 if it's on a bus, because the bus is going to be considered one of the electrical connections. So bus is a connection, and then 3 terminals. And when I say on a bus, well, it'll show up on the picture. So anyways, so you can fold it over just to give it a little bit more bulk inside your printer. Alright, when you go up to the bigger sizes, the crimper is going to look a little bit more like this. We have a couple of these. We had a couple of these. I might have to buy more. They're quite expensive. It sounds funny, but the terminals are fairly expensive. So here's the tool for it. You can rotate. If you push the button on this one, I guess. You can push the button and rotate it to be different wire gauge sizes. And you'd have to make both teeth match, right? Because right now I got a 4 and an 8. There we go. There's an 8 and an 8. And I got a picture of that here. So you see it says 8, so that would be for your 8 gauge wire. So you got to pick the right size, make sure it's the right one. And yeah, it crimps down pretty tight. Okay. I tried to demo a tool, but I didn't find a connection. I'm sure you guys can imagine. Yeah. Aluminum is only used on 6 and larger. We talked about that a couple times. They liked to say at one point that, was it right here? Might have been, next slide. They liked to say that aluminum is generally 2 gauges bigger than copper. So if you're replacing an 8 gauge copper with aluminum, you would want a 6 gauge aluminum. If you're replacing an 8 gauge a 6 gauge copper, you'd want a 4 gauge aluminum. So you'd want it to be 2 gauge sizes bigger if you were replacing a copper with aluminum. It's a question somewhere. I think what it used to be is back in the 70s or 80s where they were trying to get more aluminum wire in because copper was expensive. It maybe became more common to be doing this or save weight. And then we basically decided we just don't like aluminum in aircraft anymore. So they started kind of changing some of the questions, and there's even a prepware question that says, okay, you guys all know, not that you did before, but if you were old experienced people, you'd know that if you're going to aluminum, it should be 2 gauges bigger, right? We all know that. And then they threw a prepware question in that has a chart that says aluminum size versus copper size, and on the specific one they give you for amperages, you wouldn't. You'd actually just use the same. It was like, you guys are messing with me. Marcy, do you have a question?
Yeah, those have the answer to my question. I was just wondering why.
Yeah, it's back from, they were like, you just know that the aluminum wire is going to be bigger, but then there's a question that turns out not
start with 8, would you go to 6 or would you go to 6?
If the copper was 8, aluminum would be 6. If the copper was 4, the aluminum would be 2. Yeah. Yep. There's a chart somewhere. If they give you that dirty question on an exam, hopefully, they give you the chart to go along with it.
And then if we find aluminum wire and we want to switch it back to copper, we just reverse it 2 gauges. We can go up to 2 gauges smaller.
I'm always gonna use the chart.
Okay.
That's the old dirty general rule, but always use the chart to do that. And that's back to, man, we wanna switch it. Well, is it a part numbered wire? You're gonna go to the wiring diagram. It's gonna say, use this size. So very rare you're gonna do it. It's usually, it sounds funny, but it's often gonna be an STC or, so you can, but very, very rare are you ever gonna change something the manufacturer did and you're gonna decide, I'm switching. You better have a really good reason, not just based off this lecture today. Otherwise go to the chart. Mr. Ward.
Which chart?
It's somewhere. Yeah. I don't remember. More to the point is I'm just introducing that. If they give you that question on your writtens, they should give you the chart with it. We don't use it. I don't switch back and forth. It's kind of a back from the 70s, 80s when they were playing that game of switching it around, and we've kind of been like, no, let's just use copper and use what the manufacturer says. All right, falling objects are a hazard is one question's kind of written that way. So behind your panels, a lot of times this is what you got. You got circuit breakers. This is a bus bar, right? And this would be a prime example on a bus bar where if you had, well, that's not a prime example because I only have one connection on one side. But the bus bar, basically you've got a circuit breaker and then a bus bar, and if you had more connections stacked on top, that's where they're gonna say, well, we can't put 4 on it anymore, we can only put 3 because we're counting the bus is 1, because essentially you've got the bus is screwed to something and then 3 on top. But we wanna be really careful in aircraft that we don't drop anything back behind those panels, especially metal stuff, right? Because if it goes back there and shorts across, Samaritan Aviation, our chief mechanic when I was over there, Rob Hovenden, thought he dropped a little piece of aluminum that was on the side of the radio stack to help secure stuff, and he thought he dropped it down in somewhere, and we couldn't find it. He spent like 4 hours, and then another mechanic spent 2 hours, and then I spent 2 hours, and then he spent another 2 hours, and then we got looking, and we decided that was a different model. That was one of our other airplanes. This one didn't have the piece. He didn't really drop it after all. So about 10 hours later, trying to find it, we were like, huh, that must have been a different airplane. That's one of the problems with having airplanes that are basically identical, but there are minor components that are different. So anyway, point being, and I'll get to that question in just a sec, point being, that's how serious we are about if you drop a washer, like say you're taking a terminal off and you drop one of the lock washers back down in here, you don't just go, well, it must be down in the belly. You go find the washer, because if you've got a lock washer that came off a screw up here and you dropped it in and it ends up sitting across those 2 terminals, we got power going where we shouldn't have power. So you absolutely have to go find whatever you dropped, especially if it's metal back in those panel areas. Marcy.
One of our school airplanes, they found a pencil just like floating around right next to all the avionics, and like no one could figure out where it came from.
Where, yeah, metal pencil?
No, it was just like a regular
yeah.
mechanical pencil, but it was just like floating around.
Yeah, I mean, it happens, so just be crazy careful that you don't drop metal components back there. If you do, go find them. You can't just let them float around. Same idea goes for junction boxes. So we're not gonna leave parts and pieces in the bottom of these junction boxes. In a house or on an air conditioner, you might get away with it, but your air conditioners never experience negative G's. So we're gonna clean out the bottom. If we drop a piece down into here, you're not gonna go, I can't find it. You're gonna dig through there until you find it, and you're gonna pull it out. Marcy again.
This is kind of separate, but is that why that it's popular nowadays to flip a socket, like outlet, upside down, so that if something falls?
In aviation?
Not in aviation, but like in like the wall. Like it's popular nowadays to flip a outlet
That's news to me.
If something falls on, it fall on the ground, it won't fall into tubes.
Yeah, I could see that. That's news to me though, so sure, probably. Junction boxes should be oriented so that falling pieces don't short out wires. So what you said is if I got a circuit board in there, same idea. We don't want anything falling to land on the circuit board laying in the bottom. We're usually gonna put our circuit boards and components in the back. So exactly what she's saying for our junction boxes. FYI, if we have an electrical junction box, if it's in an area that's gonna get hot or a fire hazard, it'll be stainless steel, so it doesn't melt, right? And then oil canning, they like this on prepware. I think it's whoever writes those, you know, your writtens. They gotta get questions from somewhere. So oil canning is like the top of this is kinda convex, right? On purpose. And this is what they call oil canning, where I can go pump, 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 pump. So normally on something like that, they'll do what they call a cross break, so that it doesn't go back the other way. And pressurized, well, not pressurized aircraft, the idea would be when I put a cover on here, especially if it's sealed up, if I go fly at altitude, there's less pressure, so any air in there would wanna pop it out, and then I come back down, and they would wanna suck it in. So that question is basically just saying, hey, be aware we have pressure changes, especially in sealed boxes. We don't wanna put components or wires where if we had oil canning, it's gonna cause a problem. They like the question. What we're really gonna do is we're gonna try to avoid any situation where we could do oil canning, but be aware of that term oil canning. That's when a box might go like that because of either pressure changes or something going on. We wanna make sure that that wouldn't cause damage to any of our wires. Here's another one where it talks about no more than 4 terminals on a lug, or 3 if it's on the bus bar. So 4 on a stud, or if you're on a bus bar, basically knock it down to 3. Total number of terminal lugs per stud includes a common bus bar joining adjacent studs. Anyway, it gets a little fuzzy. 95% of the time, 4 is the correct answer. If it starts getting wordy and they start talking about a bus, well, then 3 might be the right answer. All right. Talked about this a couple times, so I'm just gonna go through quick. Always want a locking mechanism, whether that's 2 nuts or a lock washer. I just repeated a bunch of times, and I think I added it to the slideshow so that when you guys do your projects, I can be like, dude, I said it at least 10 times, at least 10 times. Locking mechanism on all our connections. We talked about that the other day, about how when you pull the wire, it's gotta tighten the nut that it's touching, so that would tighten the nut. This one, if I pulled the wire, it's gonna, is it gonna tighten the nut? That would tighten the nut. Oh, here's the bad one. If I were to pull the wire, it's gonna loosen the nut, so that's a bad connection. Bad connection. All right.
Chase, can you go back to the last slide? When you're doing that, what was you looking at connected to? It's got the little rod sticking out that.
I just call that a stop.
What does, do all like them have stops?
I'm gonna go with no.
Okay.
A lot of them do. If they do, they'll be on there. A lot of times it's actually like a straight on each side. If it's a straight in and there's not really any movement, we're not gonna be as worried about it, but most of them are similar to this, where you have some rotation one way or the other, and as you're tightening it, yeah, you wanna basically hold the wire. So if I'm tight, so if this was my, let's see, where's the top one? We'll go with this one. I'm gonna wanna hold the wire across, cause otherwise, as I'm tightening this nut, it's gonna naturally tend to push it this way, right? So if I'm not holding the wire while I'm tightening it, it's gonna naturally fall that way. But now that I'm done, if I grab the wire and pull it back over to this side, it's gonna loosen my nut. So you do have to basically be thinking about it, push the wire over, tighten it down, so that the natural position of it doesn't just swing over there and then you can loosen it back. So it's something you have to think about, which is why I repeated it a zillion times.
Didn't it swing over and then vibrate back though, and then it'd be going in, I mean, it could, like.
If it moves, the connection will be loose, and then we're gonna have problems. Basically, any movement of that nut is, now we're loose, so. And you'll see it, that nut should never, ever, ever move, that's why we do a locking mechanism. The idea is, if it's here, if I pull on the wire, I'm tightening the nut, so basically it's not gonna happen. On here, if I pull on the wire, and it's not like I do it 3 times and it's loose, basically as soon as I loosen that, it's gonna be like a breaking the friction, and now my nut's loose and it's a bad connection. You'll notice it when you start putting stuff together.
You go back a slide. Yeah, so are we required to put all those washers at the same spot, or as long as we have a lock washer or something like that?
That is how you're supposed to put them.
That way with the
Yep.
certain washer.
Now remember, there's 3 different styles of this, right? This one has the stud that's left in there. One of them has where it'll remove from it, and one of them has a nut plate. But yeah, that's why we show you the pictures over and over. There is a specific order they're supposed to go in. And the reason for that is, if you were to put a lock washer here, you're gonna be damaging the metal where the lock washer hits the metal.
Sure.
So yeah, that's why we're gonna do it in that specific order. As you notice, it's a flat washer here and a flat washer here, that way we don't damage our aluminum. But I still wanna have some locking mechanism to hold that, so I gotta add another lock washer here. But yeah, yep. It's back to, if you're installing a piece, you don't get to make it up on your own. You say, how does the FAA say I should connect this? Alright, anchored against rotation. That's where it talks about it, is the anchored against rotation. Alright, oh, that one gives you, if you got more than 4, they're just like, you know what, don't do 4, just give yourself a little bus and do 3 on each, or 2 on each, or 2 on any one, and 3 on the other. One of the big reasons we don't use smaller than number 10 size connections for that is we have to have the electricity where it can flow through the surface, the contact surface. We don't count the stud as being where the electricity is flowing. So on this, not that one. On this one, the thickness of the stud, we're not counting the stud as the electricity. The electricity is coming through the wire into the connector, and then through all those flat spots into the material or into the other connector, right? So the stud itself is not where the electricity is flowing. We don't want to count on the stud being our electrical connection. The electrical connection is the actual flat piece of this going into the washer, or the next flat piece. So just a kind of a point and a reminder that the stud's not what we're counting the electricity going through, it's all these surfaces. So you obviously then never want to put a plastic washer in there, right? Because if you're like, oh, I got it on this big thick stud that'll carry the electricity. No. The stud's not carrying the electricity. The electricity is going through those surfaces. So that's another reason you're not going to want to use a dirty, filthy, or rusty washer, is the electricity is going through all those surfaces, not going through the stud. Okay. Couple different style washers. These ones, as a reminder, you are supposed to throw them away. They're a one-time use washer. At SMAT, we don't do that. We break the rule because, well, we reuse everything here. Those are one-time use. The other style you can reuse over and over. We don't necessarily like the other style as much. They're not as easy to work with. So I recommend just using these and reuse them over and over here at SMAT. When you get out into the real world, just be a reminder, you're not supposed to reuse that style. And this is just a couple sections where it talks about, instead of having 2 nuts, if you want to, you can use a lock washer. And we're like, oh, I'm glad you said that, because 2 nuts are really annoying. So we're going to use a lock washer for pretty much everything. But the standard was 2 nuts. And then they go, well, okay, fine, you can use a lock washer. Like, yes, we're going to run with that. recommend taking a note and reading these sections. I think those are the right pages, cause it's the wrong, but, basically it's the terminal sections in your books. Just give it a read through, it's what I covered today, but, you know, maybe it's 2 weeks from now, you say, I'm gonna read through that, just for a refresher. It's a great read, it does a great job explaining, so highly, highly recommend that you, actually read it for yourself. Alright, pause that a second to see where this is at. There. Tell you what, we're gonna do a 5-minute break. There's not too much lecture left, but 5-minute break to stretch. And, so we're just gonna keep it to a short break. That'll be 8 minutes. Come back at 22, and we'll be done by 10 o'clock, 9 o'clock, excuse me, with the lecture. 40, yeah, so 20 to the hour, so come back at 8:40. Yes.
So I think
Okay.
the reason for these washers, like right here, on the corrosion, I thought it was because it almost seems like, why would you need a washer here if you had this? Too big of a deal, but yeah, you wanna have your lock washers or something that doesn't.
So washer C, you're saying?
Yeah, washer
Alright,
C.
so are we aluminum? I'm asking. Cause that material could be aluminum, magnesium, steel.
If we're aluminum.
So if we're aluminum, they're saying, basically put all the washers in. If we are steel, cadmium plated steel, they're saying you can not do
Between every
washer
item,
A.
put a washer, and then on either end, put your
Yep. And they're specific on, you know, it's a cadmium plated steel or aluminum washer. So yeah, it's, combinations of corrosion.
Okay, yeah, that makes sense.
Yeah, so if you were going to a piece of steel, now they're saying, you know what, you can skip washer A, because basically we're not worried about detonate at that point. And washer B is the same thing, where's washer B? Same thing, we're not worried about detonate. But yeah, C and D would be the ones you're questioning, and it looks like, yep, we're doing C and D every time.
Yeah. I was just wondering, cause
Copper terminal, jumper. Still has it on there, yeah, yep. Yeah, it seems like it's extra, but
it's just,
I think what it gets down to is it's just, yeah, the corrosion. Corrosion piece what they're looking at. We got electricity going through dissimilar
and this
metals.
would be for like a box or something, or just.
It could be anywhere. Most of the time, this is gonna be a ground connection. So you're gonna be grounding or bonding, if you wanna phrase it that way. So you're done with a light bulb and it's gonna be back into the frame. You're done with it. So usually these are actually the ground, because, you know, you're going to
Stack
the
those
frame.
connections, you say you can stack those?
Yeah, you go up to 4. And you notice there's nothing between them.
Yeah.
So, 1, 2, 3, 4.
Cool. Thank you.
But it is true. Yeah.
But still,
I mean, I don't know. It's like, it doesn't surprise me, it probably costs them $600 an hour, $700 an hour to run that turbo.
should just get a regular mower and just get like an Alibaba turbo.
Yeah,
Put it on there.
I'm down.
Dude.
Count me in. The shrapnel 100.
The shredder 2000.
Spin it up to like 2800 RPM. Blow it to a beat.
Well, that's not even that much though, that's the problem. Dude, no. The goal, we should get up to like 5 PSI. That'd be pretty solid. Or we just get two cheap motorcycles. I think we could do that. You should get in on that.
I'm good, dude.
Oh, there's two. Let's go.
$100.
Yeah. I'm not trying to.
I want the right one.
I want the left one. I want the green one. I'm like,
You don't need that.
$400. We're gonna rip these things, dude. No, but we're gonna.
We're not gonna do it.
Here's what you do: you drop the mowing deck, get rid of that, slam it to the floor,
I'm taking
get rid
off.
of the limiter, go right to the bar. If you get rid of the limiter, these things are.
Is there an ECU?
No, you have to rebuild the engine.
Then what limiter is there?
There's.
How is it?
It's limited.
Yeah, it's limited. It's got like, it's a small one.
You know what? I don't know, but I know that
There's
you
probably
can't.
no limiter unless there's like a little sensor we get rid of. But if there's no computer, then I don't know.
Okay, whatever. I'm pretty sure it's limited.
Stop. Stop. No.
Parts.
Go somewhere else. What year is yours?
Also, I just promised it.
Not for 1,500, but you need like $400 car.
I know.
I'm trying to think of somewhere we can do it. I just want to run it off a cliff. But,
With a brick.
yeah. You wanna join us, bro? I think you should.
Be the best 3
Oh, yeah. Just crashing into each other. Have you seen those videos?
Dude, you gotta get a Honda so you can just.
I don't know. I just want to crash it. Yes. Disconnect the airbags and just run into each other. Yeah.
He was like, MacBook.
Yeah.
But he doesn't look very good.
Yeah, as long as you can hold it open.
Yeah, but if that thing pulls over, you have to.
Well, that's for
We should get geese on it.
It's mostly when we store it.
We're all gonna buy cheap cars and then they're gonna crash into each other. Yeah.
Yeah, yeah. Yeah, especially if that helps for troubleshooting, that sounds like a great one. All right. So one piece I think that shows up later in my lectures when we're doing some wire labeling and stuff like that. I don't remember which lecture it is exactly, so I'm going to hit it now as you plan your projects, is our wire labeling. The best way to do it is to work in a shop that has an actual labeler. It's a fancy machine that you run the wire through and it just prints whatever you tell it to print all down the wire. That's the best way. Somebody actually donated one to SMAT at one point, but it stopped working. Well, because they donated it because it was old and junk, right? The next best thing is they make a machine that basically prints on heat shrink tube. So you print whatever wire you want on the heat shrink tube, and it prints out, and then you just cut that and heat shrink it onto the end of your wire. Because there's basically two things that should be on every wire. You should know the gauge of the wire, that type of information. And that one, when you're in prepware, it'll talk about every 12 inches or something, it should be labeled, you know, what kind of wire it is, where it goes. They like that question. Really more appropriately, because the wire that you buy should already be labeled that way. Some of this blue stuff or the white stuff is not. Technically, you probably shouldn't use that in your aircraft then. But the other thing is, hey, what wire is that? So on your wiring diagram, is it wire 31A or 16B or XYZ? That label is going to be at the end of every wire you have. So at the end of the terminal, it should tell you what wire it is. And if you look at all the wiring diagrams for aircraft, it has it on there. And then also, if it was to go through a compartment, so let's say my wire started here, it went through this cabinet, it comes out that side, it should be labeled on this side, it should be labeled on that side, but at every bulkhead it goes through, it should be labeled as well. That way, if you got to cut wire in between bulkheads and areas, you don't have to try to put a little wire back and forth. You can be like, oh, that's wire, well, this one's wire number 14. So, that's what we get down to labeling. So, for you guys' projects, it gets a little tricky. Historically, we don't make you label them all, when I say historically, but I don't like it. Because when you go to troubleshoot, it can be very confusing what wire goes where. So I would like to, I'm instructing you to this year, label your wires. If it becomes too much of a huge hassle, maybe we'll abandon it. So we'll see what happens. There's a couple different ways to do it. One is you can use one of those little printers that prints out numbers. Those don't stick very well if you just wrap it around. So if you're gonna do that, usually what I do is I use the little white label and then I'll put a Scotch tape around the outside that you can see through. So that's the first one I'll send around, is just, that's just a label maker with Scotch tape. I'm borderline, like I said, I don't know if I wanna make you label them all or not. It will help you eventually. What tends to work better, the problem is, these ones I've been handling, the ink will slowly come off when you touch them a lot. But if you use just a little bit of heat shrink, like these, what's kind of nice if you're using heat shrink is, where'd it go? You can write the number on it, and we used to have, and I'm gonna find it, there's a couple things that vanished at some point last year. We used to have, it looked like a black plastic printer roll that had heat shrink coming out. Those ones were nice because it was all flat already. So we had 2 or 3 of those. But basically, you're just going to take and you're going to write whatever wire number you got. So if I got wire 16, I just write wire 16 on there. My scissors. And I've got more heat shrink coming, but we got a couple bags of it. You guys aren't wiring your projects yet because you got to do it with jumper wire. So we got some time. So we're just going to take that wire 16. I'll find my wire. This one, hopefully white will shrink that far. Just put it on there, and you can put it right over the edge of your terminal if you want as well. Grab your heat gun. And nicely done, it's shrunk down. That's probably one of the better ways to do yours. So it shouldn't take too long to do that. A big part of your project is not to say, ooh, the light bulbs light up when we're done, right? A big part of this project is to make all our connections in an airworthy manner, which means while you're crimping it, you test it, and it's correct. And it only took me like 10 seconds to do that, right? So it shouldn't take too long. Where this would be a problem is if you're one of the people that's like not following the wiring diagram that you are gonna draw for your project. If you're like, let's wire it all up and we'll do the wiring diagram afterwards, this would get annoying, right? Because, oh man, I got it all wired and I don't. So back to, I highly recommend doing the wiring diagram, drawing it out, because you're gonna have it all wired on your table with jumpers, right? So draw your wiring diagram at that point, and then when you mount it on the box and you go to wire everything, you should go ahead and just label all the wires. Your wiring diagram would then have the number on it, and every terminal would have a little number on it for, oh wait, that's wire 16. I see, it goes from the back of my circuit breaker out to the light bulb. Yeah?
When you say number your wires, are you saying like, oh, this is wire number 1, which goes to connection number 1, and 2 to 2?
I wouldn't necessarily say I have a connection number 1, but every wire you have should have a wire number. So once you do your wiring diagram, just go through and say, okay, this is wire number 1, put a 1 at both sides of it, at the, where it goes to. Alright, which wire is gonna be wire number 2? Okay, that's wire number 2. Okay, which wire is wire number 3? I don't know if, like I said, it's a different PowerPoint, but, we have, every wiring diagram you look at from Cessna, or Piper, whoever it is, every wire has a number. So you're doing a project, make it so that your wires have a number as well. Marcy?
When we're like designing this kind of whole thing with these certain parameters, how applicable is that to like real life job way? Like, are we ever gonna be like designing our?
Less likely you're gonna be designing. What you're gonna be doing is making terminations, making terminals. That's very, very, very applicable, and that's actually why I stuck this labeling one in out of order, is when you're making termination connections, the FAA, and we'll come to it later, says every wire should be labeled. So you should label it. In past years, we've not required the students to like make it, this is a wire number, make it label, and what we're training everybody is to not label their wires. So for instance, if you go over to the LLC at SMAT, because we're recording, you'll see a lot of wires. It's not just SMAT, but a lot of places in the field, they don't label what wire it is. And what happens is all of a sudden you go, well, that wire's been replaced, I don't know what wire number it is anymore, and it gets hard to troubleshoot, is it in the right spot? So if you get in the proper habit of just use a little heat shrink, right on there with a pen or whatever, and label it, that's the best way to do it. One of the reasons the heat shrink is the best, or if you work in a shop with a printer, it's even better. This will not come off and get sucked into the carburetor when there's a terminal on the end, right? So the one reason not to label your wires is like that one I sent around that has labeling and then just Scotch tape. I don't think you're gonna find Scotch tape in AC 43. So I will allow that for your projects because, I mean, it's heat guns and stuff like that, and it's labeled. But you wouldn't want to do that in an engine compartment, especially on an actual airplane, because if the tape were ever to come off and then get sucked into the carburetor, it would be a thing. So just for lack of, let's say, heat guns or whatnot, if you want to do that on your project, a little piece of tape or something, Scotch tape it. Okay. Better would be, we're gonna have a ton of this heat shrink, and I mean, you're only using, you don't even have to use that much, I could have cut that shorter. You're only using a 1/4 inch for every wire you got. I'm gonna see how that goes this year. If there's lots of crying and gnashing of teeth and complaining, what I might do is switch it to say, well, you have to label at least 10 of your wires. I just want you guys to get the experience and the habit of, you know, really these all should be labeled. Does it happen in the field? Not always, but they should be. Alright, I don't know how I got to that slide. There's our break. Alright. Talking about wire bundles, we talked about it when we were doing lacing and stuff, but mostly when we're talking wire routing now for the rest of today. Wire bundles should be above flammable lines. It was really actually hard to find a picture of wires near fuel lines. When you get in the engine compartment, that gets a little bit like trickier, right? Because there's lines and they're going all over, and we don't necessarily follow the rule. But if you're in a big airliner and you're designing a panel, you're going to want the flammable fluids underneath the wires. The idea would be if you ever had a leak in the flammable fluid line and it's going to drip, we don't want that to drip on the wire. So they like that question in prepware is the wiring should be routed above lines that are carrying flammable fluid. But yeah, it's not like you're going to go through the airplane and be like, oh, there's a fuel line above a wire in my engine compartment. Well, it's going to happen occasionally. It's more when we're talking routing through the aircraft of bundles and lines when we have a choice. And that goes back to, you're probably never going to choose that, Marcy. You're just going to put back in what the aircraft manufacturer said, right? But do be aware of that. If you are adding a wire and you got a fuel line, you go, you know, it'd be better to not be below this. I should go above it. Splices, which we kind of talked about. Your airframe book talks about it around page This is the old airframe book. It'll talk about splices. Basically, you get one splice between connections, but it says damaged aluminum wire must be temporarily spliced.
Must not be.
Oh, must not be, sorry. Oh, thank you. I was reading a section in the book. I had it in the book earlier, but it's the wrong book, so I wasn't sure. They like to say splices are temporary. So if you get a wire, you can splice it for a temporary fix until you replace the wire. How often does red-green start kicking in and say, this is only temporary, unless it works? That's one of his famous sayings. This is only temporary, unless it works. Aluminum wire, sorry. Damaged aluminum wires must not be temporary spliced. You're not going to splice a aluminum wire. You're just going to replace the whole wire. That's what they're saying. I would like to push you guys to, and I don't have an extra sheet for this class, mainly because your projects take up all your extra time, and if I gave you an extra sheet, hardly anybody does it. But if I was going to add something to your extra sheet, it would be reading those spots I talked about. The other one would be go into modern Cessna 172, so like one of the 1988 and newer manuals you have online, and just start reading the front section of it and try to find like electrical sections. It'll, in there somewhere, it'll talk about electrical splices. And I think it's the 172 that gives you permission to do 2 splices instead of 1. But every modern or current service manual, service instruction, when I say modern, like 95 and on, they got really thick. And they'll have their whole own section about making connections, and how many splices, and what you can use. So I'm teaching generalities that if it's not stated otherwise in the service manual, you're gonna follow. But this actually scares me a little bit, because if you're working on Cessna 172, I mean, you're responsible to follow the whole manual. And it'll spell out in the beginning of that manual some things that are specific to that aircraft. Now, you can do 2 splices instead of 1. That actually gives you a little bit more range than what AC-43 does, right, for your textbook. But there are some things where you go, ooh, that is interesting. But yeah, we're not splicing aluminum wire. You only get 1 splice between terminals, and we don't like soldered splices, even though they're technically kind of allowed, but they're frowned upon. All right. Back to reserved for emergency. I think I used to have this slide first, is what threw me off. Splicing electrical wires should be kept to a minimum and avoided entirely in locations subject to extreme vibration. They like this question in prepware. We're trying to avoid splicing in the first place, right? So how often is this gonna come up? Somebody took a knife to your bundle, now we gotta deal with it, or what? But if you're having splices, they don't want them all stacked up in the same spot, so it gets this big ball of splices. They want you to stagger them in that bundle. The funny part with that one is like, did you get to decide where it got damaged? Are you gonna be cutting sections out? But it's a prep word question, so I'm helping you out and I'm giving you the answer. Stagger splices. The real answer is just don't splice, but you know, want you all to pass your writtens, so there we go. All right, bend radius. We talked about bend radius with aluminum tubing and whatnot, right? So we're all vaguely familiar. Did I say that right or wrong?
Closer.
Vaguely? Vaguely? We're all vaguely familiar with bend radius. What's interesting is when you look at it, does the inside of the bend radius split your bundle, or does it go on? When you start working with aluminum, they're going to be a lot more specific than I am, if I can phrase it that way. Part of that is they have a lot tighter bend radiuses. You'll be a 1/4 inch or, you know, a tiny little bend radius. And then are you measuring the inside or the middle will start mattering. When we're dealing with bend radiuses that are quite large, it doesn't matter so much. But the proper way for us with electrical wires is going to be the inside of that bundle bend radius. And the reason would be, if you imagine I got a bundle that's that many wires, and I want to turn it quite sharp, the outside wire might have a lot bigger bend radius than my inside wire, right? So we are going to look at you'd say the inside wire in the bundle if we're dealing with a bend radius. So the tightest one, because what we're concerned with is mostly that wire. So bend radius should not be smaller than 10 times the largest wire in the bundle, wire diameter. The general rule that you guys all know, because you're experts, we don't know yet because I didn't teach you, is bend radius for wires is 10 times the diameter of the wire. So if you grab a caliper and measure how thick that wire is, you're going to multiply that by 10, and that's your radius, right? Radius is the middle of the bend, middle of the circle. So the general rule is just 10 times, that's what the bend radius for wires are. And then we start making exceptions, yeah.
Is the 10 times, maybe you said this, the wire or the insulation?
Insulation as well, yeah, the whole thing, yep. 10's a pretty big sweep. On the one hand, you're like, well, that's a pretty small wire, but if we measure this is probably, what, a 1/16 of an inch on that one? So 10 times 16, 1/16 is, uh-oh, that was bad math. I shouldn't have done that. 10/16. So a little over a ½ inch, right? So they're expecting a little bit over a ½ inch bend radius. Is that gonna be pretty hard to measure? It sure is. What they're worried about is they don't want that. Is that one a ½ inch bend radius? No, right? So if you have to measure them, maybe we're gonna think about it, right? But we don't want to kink our wires over is what we're after. And then we're gonna teach you the technical, because if I just said don't kink your wires, you're like, well, technically it's what's kinked. And I'm like, well, yeah, that's where we're going. So 10x is the normal. What they do then is they start changing it. Individual wires, if it's supported, and when we say supported, notice they got the support clamp on there. If you got it supported so that it can't get tighter, you can go down to a 3x. Now there'll be some words that call reversing. You'll see if a wire's reversing from a bundle, the idea with that word reversing is the wire's in my bundle, and we'll call it, it's running this way, and it's gonna say, hey, we're gonna go head a different direction. So I'm gonna turn around and head that direction. That would be reversing. I mean, technically a 90-degree sweep coming out of the bundle, we're still reversing. We ain't totally reversed, but we're half reversed. We half started going the other direction we're going. So that's what they talk about when they're reversing. So it's that bend radius there. So if you have a bundle, we're essentially saying in the bundle you're supported because you're bundled together with your lace, right? Not your Dynatie. In the bundle you're supported. If it's supported outside as it's going somewhere, they'll let you go down to 3x. That's a really tight, that's tight. If it's not supported, you're back up to, I believe it's your 10x. This one shows 10x. There's one spot in AC 43 that says if it's a bundles actually reversing from another bundle can be as small as 6x, the wire diameter. If I have, that's what it is. If I have a bundle reversing, they'll allow me to go, that's a bad picture. Say I take 5 wires out of here, they'll allow me to do 6x on that one. So individual wires can go down to 3x, bundles reversing are 6x. The whole bundle itself is 10x, and the other general rule is an individual wire is just 10x. Now, the back of your circuit breaker, how tight can you bend one? Well, that's basically going to be open to some interpretation. But from everything I'm seeing, as long as it's supported, you can go as tight as 3. So for instance, this one here, that one's probably too tight because is it supported anywhere? Not, your way. So non-supported, so really I should have a 10x bend on there. That's not a 10. if I was to put a lace on here, now this one would be supported, so I can go down to as low as 3. So just be aware of that in the back of panels. Here's some more tight ones that appear to be supported with a cable tie. I don't know where I took the picture from, but so yeah, you get a little bit different bend radius if it's supported or if it's not. I will be looking at your projects. If I see wires that are like kinked back on each other, I'll be going, they were not thinking about bend radius on their wires. When you're running it through the aircraft, they don't want it tight like a guitar. They want to have some slack. So they'll say, it says maximum, so we want it slack-ish, so it's not pong like a guitar, but they don't want it to be flopping around. When I'm flying with Joe, and I'm the guy doing bad landings, oh, I almost threw you under the bus, but not quite. And we hit the ground really hard. I don't want this to have an inch of slop to where it's going kaboom, kaboom, kaboom every time we do a bad landing. So they're saying ½ inch max. So we don't want it tight like a guitar, but we do want some droop in there, but not more than ½ inch. This is funny. Hand pressure? Is it Case's hand pressure or Job's hand pressure? Or maybe we should switch that up and say, is it Israel's hand pressure or Case's hand pressure? That's the idea behind it. This is flexible conduit. This is not typically used in aviation. I thought I had a piece to pass around. I'll check if it's in here real quick, and I might have to pull out the next class. There it is. Whenever I hear the word conduit, I think this metal conduit. That's not what your brain should run to. You really use that in aviation. This is conduit, flexible conduit. Basically, it's protecting our wires that are running through it. So when you see that, that's what you should be thinking. So wires that are in areas where they might get damaged are going to be run in conduit. So a lot of our landing gear areas, we're going to put our wire in conduit. So that'll help you be like, what? No, it's not this. We're putting it in something like this. Pulling wires through, if they don't want to slip through that very good, we're going to use what we call powdered soapstone. It's kind of a talky stuff. It's dry. It helps them slip nice. You're not going to put oil. Why wouldn't we want to use oil? Yeah, I didn't even think of that one. Flammable. It's going to react with our insulation as well, and it might start to weaken our insulation and make it nasty, gooey. So we don't want to use any oils. If you worked in this industry in the past, they'll use kind of a goo. It's like a clear, gooey stuff. We don't want to use that in aviation. We don't want that wetness sitting on our wire for the next 50 years. So powdered soapstone is the correct material to use if you're having trouble pulling your wires through in an aircraft. Say we got conduit that doesn't have all holes in it like this, because some of our conduit is going to be made out of more of a vinyl, if I can phrase it that way. If there's a low spot, we'll always have a hole in the bottom to drain any water out that gets stuck in there. Grant, question?
I had a question about the previous slide. When you have a conduit and you need to label it on the outside, right? Can you still use heat shrink and like all your other methods? Does that still work?
Actually, if you go to ACA 43, the one space they're really clear about cable ties being permissible is when you're labeling bundles. So what they'd have you do is use 2 cable ties around a label to label that bundle. The cable ties actually hold the label on. So you might be able to heat shrink it, but they're actually going to prefer that you cable tie a label onto it. The cable ties secure the label, not the wire.
Okay.
You probably could heat shrink it. Problem if you heat shrink it, it's going to shrink, and then they're all pinched. Now I can't pull any more wires through. So I don't think you'd see that. What you're going to see is the cable ties on a label on the outside. All right, so drain water. I have done a lot of heating and cooling work where conduits go underground and they're not supposed to get water in them. But man, 20, 30 years later, it's been sitting, those wires have been sitting in water, and some of them have shorted out, but the insulation's pretty good on most of this stuff. When you go to pull the wire out, it's just black and nasty. And, ugh. So we don't want our wires and our insulation sitting in water. That would be a problem. So if we have a conduit that's got a dip, we will have a hole in the bottom of it. I wouldn't wanna drill that hole while the wire's in there, would you? No, so chance of you making one of these are slim to none, but you would drill a hole in the conduit before you fish the wires through. Drill your wires, yeah. We are gonna use clamps. These are unbonded clamps in aviation. No more than 24 inches between them. It's saying secure every 24 or less. There are spots where they're like, well, you're gonna lace it if it's more than 12 inches apart, right? So I'm not 100% sure where we made the jump from 12 to 24 and why we have the inconsistency, but they're telling me you're gonna clamp it every 24 inches. So you probably could have said you should lace it if it's, but that's where we go.
When we label our wires, these wires get really long. Is there a certain distance you're supposed to have to label, so it's just one end?
So there's two different things you would label your wires with. One is if you're the wire manufacturer and you're labeling 12 gauge, 12 gauge. That one's where it's got it it might show up in a later slideshow, it's like every foot. You're probably not gonna put that label on.
Yeah.
You're gonna put wire number 13. That one is gonna be at both ends and anytime you go through a bulkhead. So the wire number 13 doesn't have to be every, foot or 12 inches. That one that's every foot or 12 inches is really designed to say what type of wire is it. Now, the manufacturers like Boeing and whatnot, they do us a favor. They will typically have it be wire 37 and every foot it'll be like 37, 37, 37, but that's just because they're nice. All right, interesting part with clamps is this one always kind of threw me off. What we're worried about here is, imagine we got a wire in a bundle. We don't want one of our wires in our bundle to be able to fall down in between those two pieces of metal and essentially get itself pinched. So that's what they're talking about, which totally makes sense with these ones and this one, right? This one's a little bit trickier because you're like, I don't know, that's kind of up. How is a wire gonna fall? So they say I don't know. Especially because then a little bit later they give us this picture. And this, to me, looks worse than this. But you gotta work with what you got. Those flat ones are gonna be less of an issue, right? The main thing would be we don't want this and we don't want this. The reason I came up with, the closest I can figure on them not liking this, is the weight of that clamp is pulling on the securing screw, and it's gonna tend to pull the clamp off the material. So I think the reason they don't like this one, after a whole bunch of research trying to be like, I don't get it, was this is underneath a piece of aluminum and they don't want that clamp, the weight of the wire, to bend the clamp. These ones, the weight of the wire is not gonna bend the clamp, so it's not an issue. So it's just a little bit confusing on the reason we don't like it there is not because the wire is gonna fall into the crack, it's because we don't want the weight of the wire to bend that clamp. They would say, put a 90-degree and hang the clamp vertically in a situation like that, so the weight of the wire doesn't try to bend your clamp. So they kind of mixed two things on this particular picture.
Could you theoretically put something in that space so that the wire doesn't get pinched? Because if you maybe had to.
On these ones, you mean? They're gonna say spin it around.
Well, I meant like.
So it's like this.
The ones that.
Oh, these? And that's back to sideways, it's not, that's why this one's confusing. That one, it's got more to do with the weight of the wire bending the clamp than that sideways is wrong. So that's, I don't like the picture and that's why I'm explaining it to you. Cause here's a whole bunch more clamps that are sideways, right? So it's back to the sideways part is not the problem. Notice the support is underneath this, so the weight of the wire theoretically isn't trying to bend the clamp again, but yeah, we're in a bit of a gray area. But these pictures, the main thing they're saying is the gap between the wire and the sharp aluminum's gotta be at least 3/8 of an inch. If it's not, you'll have a grommet on there to protect the wire in case we get some vibration. crosstalk is kind of a funny word they use. You know, a capacitor has that whole dielectric thing. There's capacitance that can mess with our avionics especially. We've got two places that electrons can hang out. There's insulation between them and there's a distance. So they're terrible capacitors. It's not a good capacitor, but theoretically there is a measurable capacitance when you have two pieces of metal somewhat close to each other, especially if you're talking a 10-foot run. Now we've got those pieces of metal might only be, you know, an 1/8 inch apart for 10 foot. So there's some level of capacitance there. So what they'll try to do is either not run wires that are going opposite directions right next to each other, because that will amplify it. And or what they'll say is if you got one wire carrying electricity, it'll tend to cause the other wire to push electricity the other way. Very, very minimal, usually not an issue. If their communications are sensitive lines, we'll usually use a shielding around them. But that word crosstalk is a word they like you guys to be somewhat familiar with. Just so you go, what crosstalk? I have no idea what crosstalk. It's the wires kind of act like a capacitor, so the amperage going through one might influence what's going on in the other wire. An extreme version of crosstalk is I had an air conditioner that the wires went all the way through a building in a conduit, and it was super high amperage when it started. So that super high amperage made the wires actually jump away from each other if you use all the hand rules. So that's a version of crosstalk in that they push the wires apart. More in aviation, we're concerned with avionics and stuff. Yeah.
Do you guys use fiber optics on aircraft?
We don't learn about them at SMAT. I'm gonna go with yes, but not in the stuff we're gonna be dealing with. When Anna went down to Alabama for her avionics school, they started just slightly dabbling in it, but it's gonna be more of a specialty. So I don't wanna say no, because it is showing up, but it's a specialty area that you're not required to learn for your AP. I'll put it that way. Alright, tomorrow is our magneto class, so I didn't necessarily go over this connection that you're gonna have on your shielded wire for magnetos. So we'll go over that tomorrow in more detail. I will point out we got a ton of this blue wire that's free. You'll definitely want to fold that over on itself if you're making connections. I'd love it if you use that stuff up. Very similar with this white stuff. Otherwise, I did buy a bunch of these little rolls of black, so that's kind of my anticipation of what you're going to be using. Dean, because he's cost conscious when he takes apart your boards. We got a whole box of pieces, so if you just need a 6-inch piece, that's what these are all. It's all reusable, right? So instead of cutting 6 inches off a roll of this, we got a lot of it down there. Now, when you go to do your magneto wiring, you're going to use the official coax for magnetos. This isn't radio coax, it's shielded. I guess technically it's not coax, it's just shielded wire. This is the official stuff. It's quite expensive. I want to say a couple bucks a foot for this stuff. So if we're doing it on actual aircraft out in the shop, I recommend using this because it's better practice. We have a whole roll of coax that they use for phone lines and stuff. It's smaller gauge, so bigger number. So on your projects for magnetos, if you want to try or if you want to just practice a couple times, it's a little trickier to get it stripped, but this is coax cable, and it works just fine. I would be like, you get bonus points if you use it on your project. I don't know. I don't really give bonus points, but you're more than welcome to use this, especially for your magneto wires. Even though it's not the official correct, I prefer this one. But if you want to use the official correct, you'll just eat through my $4 a foot stuff. So that's what we do have. And other than that, there's a ton of other wire out there. And as a reminder, most of you aren't going to have a high amp draw load, so we're not going to have to worry about wire size. I don't really care about circuit breaker size in this because, I mean, they're little 1-foot wires. So we can kind of ignore all that wire sizing, but I say it again to say if you were in an actual aircraft, we would care about wire sizing. for your projects, not so much. Now, if you run a 10 amp load on one of these little dudes, we might wanna think about it, but the reality is, if it's only a foot long, this probably would still carry 10 amps if we go to check the chart. So, okay, question?
Yeah, do you want us to use that because it's shielded, is that right?
Yeah, when we do magnetos tomorrow, the wires going to your ignition switch or your mag switch, you wanna use shielded, cause I am gonna be looking for the correct terminations on your shielded wire for the mag switch. Yep. Yeah, you're not gonna run your whole project in this, just the mag switch wiring. Alright, that's it. Dismissed.